Right now, tech startups and developers are racing to build custom AI agents. A different bot for marketing, another for legal, another for finance. This requires constant coding and separate toolsets for every new use case, creating a fragmented network that is difficult to maintain at scale. But Anthropic, the creators of Claude, have offered a different directive. They are advising developers to stop building agents and start building skills. A skill is a plain text playbook. Instead of engineering a new AI from scratch, you hand the model a document of exact instructions, providing a generic model with specialized expertise. To see exactly how this works in practice, we are going to use Claude Code to run a full Generative Engine Optimization, or GEO, audit on a live website, powered entirely by one of these simple text files. Setting this up acquires a lightweight environment. You just need Visual Studio Code, access to Claude Code, and a downloaded repository folder containing the skills. Adopting this modular framework allows you to pivot between tasks without constructing or maintaining independent AI architectures. You rely on one core model and simply swap out the playbook. Modern AI models possess immense raw analytical intelligence. They can reason through complex math and write code. However, specific business workflows require a level of nuanced expertise that general reasoning alone cannot provide. Think of it like doing your taxes. You could hire a certified genius who has never filed a return before, hoping they figure it out from first principles. Or you could hire an experienced tax professional who already knows every deduction and edge case. For complex workflows, you want the professional. Because baseline AI models lack your specific business memory, the standard practice has been to build separate, custom-coded bots for every department just to force them to follow specific workflows. Anthropic proposes maintaining one universal underlying engine that can instantly access domain expertise exactly when it needs it. This works through an architectural concept called progressive disclosure. When Claude starts a job, it doesn't load every single instruction for every possible task at once. It just reads short descriptions of available skills, scanning titles on a bookshelf. Only when a particular skill is needed does it pull that specific manual off the shelf, reading the full instructions into memory. Progressive disclosure allows a single model to hold thousands of specialized workflows. The AI stays focused on the active job, without the context becoming cluttered by irrelevant data. Let's look at how this is actually built inside the developer environment. The entire setup lives within a standard folder hierarchy in Visual Studio Code. At the core of each specialized folder is a simple markdown file, typically named skills.md. This text document acts as a strict set of operating instructions. It dictates the specific tone, structures the final output, and defines the mandatory steps. These skill folders are also highly extensible. You can place standardized reporting templates, reference documents, or even executable Python scripts right next to the text file for the AI to use. Since core operating instructions are just plain text, the ability to build a customized AI workflow is available to anyone who can write clear steps. Absolutely no back-end coding is required for this. To initiate the workflow inside the Claude Code terminal, you simply use a / command. In this instance, selecting /geo audit. Plain English queries work just as well. Claude cross-references your natural language request with the spines of its available skills to automatically select the correct workflow. Step 1 of the execution begins immediately. The skill triggers a discovery phase, scanning the target website to gather initial data. Once the initial data is collected, the workflow enters phase 2, utilizing a feature called parallel subagent delegation. The main skill playbook acts like a general contractor building a house. To analyze the website efficiently, it spawns 5 separate subcontractors, or subagents, tasking each one to process a different piece of data simultaneously. Embedding subagent delegation within a single skill instruction reduces overall processing time and produces a more comprehensive analysis than standard linear chat prompting. The subagents finish their concurrent tasks, compile the data, and generate the final local file. Opening this file reveals a structured generative engine optimization report, featuring an executive summary alongside a prioritized action plan. The audit delivers specific business insights. For example, it flags that the target company lacks a Wikipedia article, detailing exactly how this absence hurts their visibility in AI search results. We took a single URL and turned it into a structured, professional deliverable in minutes, reliably generating data-driven products for clients. This structural framework is adaptable to various industries. By loading a different text file, the model can pivot to executing complex legal contract reviews or formatting financial reports based on your firm's standards. Managing massive prompt contexts and independent agents is no longer necessary. Building highly organized modular skill libraries allows a single model to scale across diverse workflows without the overhead of custom-built architectures.